All right. Here we have another interesting problem, illustrating how we should use Newton's laws. So we consider this type of system here with a mass m, and it's attached to this axis here by strings of length L, also here length L. And the angle between the axis and string here is 45 degrees and also 45 here. And by extending this string as a line here and see that it's 45 degrees over there, we realize it's also 45 degrees over here, that angle. And you can see if that's 45 and that's 45 and you have a triangle here, that the sum of the angles must be 180 degrees. So we know it's 90 degrees here. And if it's 90 degrees here and 45 here, it must be 45 degrees here. So we already know something here. And what we need to do is to form Newton's laws in the x direction and also in the y direction. And then we get a couple of equations that we can use. So here are the string forces T up and T low, and we also have the gravitational force mg over here. So let's look at, for example, T up, the triangle. So I can do this. Something like that, approximately. So the hypotenuse here is T up. And the angles here are just 45 degrees. So let's say I look at this angle here. That's 45. So you have one side here. And that is T up sine 45 degrees. And sine 45 degrees is just 1 over square root 2. So it's T up over square root 2. And also here, that side is T up square root 2. And if you use Pythagoras' theorem, you can see that the square of that should be the square of that side plus the square of that side. And you can see, yeah, that makes sense here. We can check it. T up squared equal 1/2 T up squared plus 1/2 T up squared, which is equal T up squared. So yeah, it makes sense. So let's take a look here now. Forces in x direction. So what kind of forces do we have in x direction? Yeah, that's the question, isn't it? So here is the x direction. And you can see the gravitational force mg is in the negative y direction. So that is certainly not the x direction. At the string forces here, you have one component here of the T up in the negative x direction. You see, x direction is in this direction. So the force in the other direction is negative. So it's a negative direction here. And also the T low, this string force, has a component in the negative x direction. So let's write that down. Okay. Minus, at least I tried to do a minus there. T up, square root 2, minus T low, square root 2. And there are no other forces in the x direction. And according to Newton's second law, the sum of the forces acting on the particle m equal m and the acceleration. But in this case, the acceleration is in the x direction. Okay. And as we can see here, the particle is making a circular orbit. So we have centripetal acceleration. And the centripetal acceleration is directed inwards towards the rotating axis. So it is not in the positive x direction, it is actually in the negative x direction. So it will be a minus here, and the centripetal force is omega squared, the distance to the axis which we are revolving around, and that is L over square root 2. So that distance here. So if that distance is L, that one is L over square root 2, and also that L over square root 2. So that's the one here. So then we get a simpler result. Actually, we can now write T up plus T low equal m omega squared L. This we call equation 1. And the next step is doing the forces in the y direction. Forces in y direction. And if we go up, we can see there are string forces in the y direction and also the gravitational force. And you can see the T up is in positive y direction as a component. This T up, it has a component here in the positive y direction. T low has a negative component in negative y direction, and mg is also in the negative y direction. So let's write down these. So we had T up square root 2 minus t low square root 2 minus mg. And according to Newton's law, the sum of the forces should be equal m multiplied with the acceleration in that direction, in y direction, m ay. But the particle is never moving in the y direction here. It's revolving in a plane orthogonal to the y direction. So there is no movement ever in the y direction and no velocity in the y direction. So the acceleration in that direction is 0. Okay. Then we can again simplify a little bit. T up minus T low equal mg. This is equation 2. And let us now add equation 1 and equation 2. 1 plus 2. What do we get? We get 2t up equal m omega square L plus mg. I made a mistake in equation 2. Let's see here. This one. Let the mg over to the right side, but I forgot about the square root 2. So it should be a square root 2 involved here. Okay. Like that. Okay, so, and when we add the equations, it will be square root 2 here also. All right. And this last expression can be simplified. T up equal 1/2 m omega square L plus square root 2 divided by 2 is 1 over square root 2 mg. Okay, and the t low can also be calculated by simply taking equation 1 and subtract it from equation 2. So it's a trivial continuation of the same thing. Let's check if it's fulfilling. In the problem text, we see if omega squared L equal square root g, then we get this result. So, okay. Square root L omega squared square root 2g. Square root 2. So, okay. Omega square L equal square root 2 g. Yeah. G. Okay. What happens then? Okay. What do we get? T up equal. And we have a half here. So we get m g over square root 2, and then we have plus like this, and that's 2 mg, which equals what? Square root 2 mg. And this is exactly what we had in the problem text, what we should get. So that you can see here. T up should be square root 2 mg if that condition is fulfilled. Square root 2 mg if this is fulfilled. Okay, let us derive the string force T low from equation 1 and 2. Here's equation 2, here's equation 1. If you take this equation and subtract it from this equation, you will get 2t low like this. 2t low equal m omega square L square root 2 mg. All right, can you see that? This minus that. Yeah, so that's correct. And when at the moment this string force T low here, when it's 0, it is just about to destroy the static situation we have here, and then the mass would start pendulum down here somewhat. So we need to maintain this, at least this radial velocity, I mean angular velocity, omega, or greater. Otherwise the system here collapses. So T low equals 0, and what do we get? From this we get omega equal square root 2g over L. So actually omega equals this, or actually larger. Thank you very much. See you later. Bye bye.